Hi, Algebra 1 students. I noticed in the last recording that there's a little bit of delay with my voice and the video, and I'm not sure why, so I'm trying on a couple different computers. But for today, what we're going to do is I had some of you, and I have to find where I put them. Some of you did send me questions, and so I'm going to try to answer some of those. So I'm going to do some of the homework questions here in a second, but I did have a few questions that I think could be answered pretty quickly, so I will attempt to answer those first. So one of the questions that was asked is, how do we use this in the real world, and why is this necessary? And so one of the things that I usually explain to students is that in order to use this in the real world, you have to be able to get to the real world. And so getting through high school and then taking the SAT and getting through college, those are all necessary steps to getting to the real world. Once you get to the real world, then there is the whole problem solving thing that you've learned in your math. So in Algebra 1, Geometry, and then Algebra 2, you're doing a lot of logical problem solving. And so hopefully that helps you when you get to real world scenarios and you've got to either use statistics or math or processes that help you problem solve in your company or in your classroom or whatever you might be doing. That's the first answer. The second one is, who decided the different math rules? And without going into a lot of history, if you were to go into math in college, you would study the history. Who first came up with the ideas for algebra or geometry? And that is something that I'd like to see the histories of the math incorporated. But those people and those cultures that came up with the maths are the ones that set the rules in place for those things. So I will look for a brief history of algebra, and if I find something, I'll include it as part of our classroom learning over the course of the rest of the year. So maybe it could count as an extra test or something. All right. Then there are a few questions that are what I would call general questions before we get to the homework. So let me take a look at those. Get the board a little bit closer and the camera a little bit more on it. So one of the things that was asked is to please list the steps and I'm assuming it's listing the steps to actually get a parabola on the graph. So if I were to give you an equation like this, y equals 3x squared plus 2x plus 6. The person asking the question, I am assuming, wants to know what are the steps to get that on the graph. So I'm going to list those, and I hope that you will write them down as I list them. So the first one is and I believe you might want to know this for the test that's coming up, but somebody also had asked about it. I don't know if it was for the quiz or just in general knowing there's 5, maybe 6 steps that you could use. So the first one is to put it in standard form. Put the equation in standard form. So if these numbers were on the other side of the equal sign, you want to get those in standard form. The second step then is and this could be a separate step or all one step, is to list the A, the B, and the C. So our A in this one is going to be 3, our B is going to be 2, and C is going to be 6. You could make that 2 separate steps if you wanted to. I kind of tend to make it A and B. Then the third step to remember is the vertex. and that's negative b over 2a. And again, this could be kind of a little two-parter, or you could put it in separate parts. So the vertex in this case would be a negative 2 over 2 times 3 is going to be 6, or it's going to equal negative 1/3. So putting the vertex formula, finding the vertex. There's another step. Then you want to come up with your table of solutions. And in this one, our vertex was running along the negative 1/3. That's going to be in the middle. And then you would have 0, 1, 2, negative 1 maybe, and negative 2. I'm not going to go through and find all of these. I'm just giving you the steps. And then finally, you want to plot the points and draw your, don't forget the draw part. Some of you like to just plot the points, and then I can't tell what shape you have there. So here are your steps, 5 of them at least, but you could break a couple of these out into additional steps. So on the test, it is going to ask you for these steps, and you should be able to list these for me. So hopefully that answers the question for the person who needed to know the steps. All right, another question. And you guys had some good questions, so hopefully we can get through those. And then I'm going to introduce you to the packet that you're working on. So somebody asked about the dotted lines. So when we have, let's say we have a parabola that's doing something like this, maybe. And this is maybe our equation. We're going to do a pretend equation here. 3x squared plus 4x minus 3 is greater than 0. Okay, so we're just pretending. I don't think that's what's going to come out here. But this was, the question was about this. And so this would mean I have to put a dotted line. And then, because there's no line under, it has to be dotted. That means that the line, the solution cannot be on this line if it's dotted, if it's just greater than or less than. So that means what I shade, let's say that the shading is out here. And we're just pretending on all of this. But the biggest part is that the solution cannot be on this line. Now, if it had the equal sign, which is what that is that I just drew in, this is the equal sign, then this would have to be solid. You know how badly I draw these lines here. This has to be solid. And that means that the solution actually could be on this line. So the solution can be on the line or it can be out here. Okay? So it could be on the line, it could be out here. But if it is dotted, it cannot be on the line. So for our student that asked that hopefully is the solution. If you still don't understand that, you need to get in touch with me. And then finally, somebody asked, what about no solutions? How do you know if there's no solutions, or what does no solution mean? For us at this moment in time, one of the things that it means, if I draw a parabola and it is above the x-axis, there's no solutions as far as where it crosses the x-axis. So no solution as to where it crosses the x-axis. If it hits the x-axis at one point, whoops, I didn't draw that very well, then there's only one solution. if it crosses in two places, then there are two solutions. Now I skipped over the chapter that was called the discriminant chapter, and I think that might be what is causing a little bit of the confusion. So we're going to take a quick look at that before I do these other couple of problems. So if you'll take a look at chapter 9, we're going to go to, and I was kind of just jumping ahead just to save some time, but 9.7 is on 540. And the discriminant is the piece that is in the radical, the negative, or the b squared minus 4ac. And I'm just going to simply explain what this is. And if you look in the blue box there, it says if the value of b squared minus 4ac is positive, then the equation has two solutions. You're going to find the two places where it crosses. If the value of b squared minus 4ac is 0, then it has one solution. That means it's going to bump across the x-axis in one place. Finally, if the value of b squared minus 4ac is negative, then the equation has no real solution. And so if we come out with a negative number in here, we've already talked about how you can't have a negative in there. That's going to be your no real solution. So we skipped over that. It probably would have been helpful to have taken a look at that. So we're going to take a look at a couple, or one of the checkpoints in here. And all you really do is take this, and there's none of these on the test. But we're going to look at let's look at example number 2. And we have negative x squared plus 2x minus 1 equals 0. Our a is negative 1, our b is 2, and our c is negative 1. So we're going to plug these numbers in. B squared, 2 times 2 is 4, minus 4, a is a negative 1, c is a negative 1. Now, we notice that something's going to happen here because I have 3 negatives. That means there's going to be a negative something here. So negative 4 times negative 1 is going to be a positive 4. Times a negative 1 is going to be a negative 4. So I'm going to end up with 4 minus 4, or 0. And we already learned from the blue box that if it is 0, it's going to have one solution. That's where your parabola is going to bump, and that's what I like to call it, bump the x-axis, okay? If it had been positive, then you would have two solutions. That's two places it crosses. And if it is negative, there's no real solution. And I've told you that sometimes your parabolas are going to be up here, so there's not going to be a solution for where they're crossing the x-axis. So I hope that clears that up a little bit. You're not being tested on just that piece. You know how to use the whole quadratic, and you know how to find solutions that way. So I'm skipping over that. All right, there were a couple of homework questions. Let me find my little pad of paper here. So on page 557, so everybody turn to 557 so we can all learn together. And 557, number 20. Use a graph to estimate the solutions of the equation. Check your solutions algebraically. You do not need to do the algebraically piece because if you are just in the ballpark, they're not going to come out. So I don't like to add that piece in. So we're going to have x squared minus 4 equals 5. All right. And perhaps the part that's hardest on this is that we don't have an x component in here. And so I always like to add it in. So I'm going to change this. I'm going to move this over to join him. I'm going to have x squared minus 9, or excuse me, let me put my x piece in first, plus 0x minus 9 equals, and we would have either the 0 or y there. Now what this does is it helps me remember my a, b's, and c's. So my a is going to be 1, my b is going to be 0, and my c is going to be negative 9. Then I'm going to go for the vertex, which is negative b over 2a. Well, I know that's 0, so my vertex is going to be 0. And I'm keeping up with it in my little solutions, and so far we're right on all of this. The next thing we want to do is come up with our solution table. And hopefully you guys can see this okay. We're going to put 0 in the middle, 1, 2, negative 1, negative 2. And so when we put 0 in for everything, we end up with negative 9. When we put 1 in, we're going to have 1, this is always going to be 0, minus 9, which is negative 8. When I put 2 in, I'm going to have 4 minus 9, which is negative 5. Negative 1, and here where my symmetric thing is coming, and same thing here. So now I can plug everything in. So I'm going to, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. So here is where my vertex is going to land. 1 and negative 8 is going to be there. And negative 1 and negative 8 is right about there. And 2 and negative 5 I think is right about there. And negative 2, negative 5. All right, and then I'm going to erase all of this so we can get clear here. All right, not too bad. Now this was an equation, so we do not have the dotted line. And here is where I'm crossing. Now this one doesn't work nearly as well with the eyes and the nose and all that, unless he has a really long snout. But here are my two areas that I want to find out. This guy has glasses, baby. And then he's just got a big nose. And so I have to estimate. And so I'm going to look on here and I'm going to kind of guess that somewhere between 2 and 3 on either side. So I'm going to put plus or minus 3, but a question mark because it seems to be in that area. And so depending on how you did yours and how well your lines came out, you could also really keep going with your table of solutions to try to get as close as possible. But again, on these where you're guessing by graphing, it's a ballpark answer. So don't then try to solve it algebraically. So that was one of them. And the other one was number 15. So let's take a look at that. And number 15 is one of our radicals, so we're going to have the square root of 27 over 45. Now, as we're reviewing for the test, you are going to see some of these. So remember a couple of things about this. Remember that you're going to split them. That's the first thing. And then, so Josh Cardozi made an excellent video when I mentioned about breaking these out of jail. So like he sent me a video with like these guys trying to break somebody out of a house or something. But I want you to remember that. You want to break as much of these guys out of jail. You want to get them out of their houses if possible. So a couple of things we want to do is we want to begin to break these apart a little bit to see if we can come up with little segments that we can actually break out. So for the square root of 27, if we did the square root, if we did 3 times 9, we could potentially break out. We divide it up. So we give them each their own house. So if we do that, then this one can actually break down to 3. Now don't get rid of this guy. Seeing you guys, it's like sometimes the radical signs just completely disappear. You can leave it like this, or you can put 3 times the square root of 3. That's what we would leave on top. So then on the bottom, or this bottom number, we want to do the same thing. Now we could do, let me think. We could do 3 times 15 and 5 times 9, I think works too, right? Square root of 5 times the square root of 9. Yeah, I had to think for a minute. Totally losing my brain at this point. And here we go again with the same thing. So I can break this one out. And I can make it times the square root of 3. So then I would have, if I come back over here, I'd put 3 times the square root of 5. Now, if you are at all up on your fractions, and I hope you are, you would recognize that you can get rid of that. And you're left with the square root of 3 over the square root of 5, which is not the right answer. So I did something wrong there. So we're going to do it again and see if we can come up with the right answer. So hopefully you guys can figure out what I did wrong. So we're going to do it again. We're going to start all over again and see if Mrs. Jernigan can get it right. 27. What would we divide down there? We would divide the square root of 3 times the square root of 9. And we break this one out, and we have 3 times the square root of 3. Oh, I know exactly what I did wrong. All right, we're going to just keep going really fast. And then we would do, in this one, we would do the same thing, square root of 3 times, or 5. See, if we had been in class, you guys should have screamed out, Mrs. Jernigan, and told me what I did wrong. Times the square root of 3. So we would have the square root of 3, and this would come out. Now, what you should have screamed out, and hopefully you're screaming out over the airwaves, is Mrs. Jernigan, we can't leave a square root in, right? We can't leave a square root down here. So we have to now get rid of that. And maybe that's the problem that everybody had. So we have the square root of 3 over the square root of 5. To get rid of that, remember we want to multiply times the square root of 5 in both the numerator and the denominator. And when I do that down here, the square root of 5 times the square root of 5 comes out to be the square root of 25. And we all know that that is 5. And up here, the square root of 3 times the square root of 5, you can leave it like that, but the preference would be to make it the square root of 15. And that is the right answer. So this is not the right answer. Don't stop there. That was an excellent, I'd like to say I planned that, but I didn't. But remember, you can't stop right there because you cannot leave your square root. You've got to come over here and then multiply it by this in both places. And then this is your final answer. So that might have been the issue that the person who asked the question was having. Okay, so the video has gotten pretty long. I want to introduce you to the practice packet. It's been posted on Sycamore, and it has come out of just a little workbook that I have that goes along with your textbook. I didn't do all the pages. Each page has maybe 3 or 4 problems on it. You have instructions for Monday evening to begin working on this. I would say set your timer, maybe work 20 minutes, and begin to work through the problems. And then you're going to finish it up on Tuesday. Then Wednesday at 11, I will be sending a link. We will have a live Zoom tutoring session, and I'm going to have my whiteboard out, and I'll have the Zoom camera or the Zoom all set up, and we'll be live. You'll be able to chat with each other for a minute, and we'll probably go about an hour. It's at 11 o'clock, same time we would normally have class. If you downloaded a HAS that says 1 o'clock, that is wrong. I went back and changed it. It is 11 o'clock. And so on Zoom, and I'm going to try to record it. I've recorded on Zoom before and not been terribly successful. I am going to try to record it. But we will go through or at least one problem in each of the sections on each of those pages. And I am going to try to work through them to be able to send you the answers so that you have those to work with. I don't think I have the answers in my book, but I'm going to try to work them between now and tomorrow night so that you have them. So Wednesday at 11, we Zoom, and then if there's any other, if you're having trouble, we still have Thursday. The test will be Thursday or Friday, depending on when you want to take it. It has not yet been posted. It will be posted on Wednesday after the Zoom session, and you can take it any time after that. So if you have any questions, if I've not answered anything or some of these very clearly, please let me know. I'm starting to get a little loopy with all these videos, so just feel free to follow up if you haven't understood something. So I will plan on seeing you Wednesday for the next Zoom session, or for our Zoom session, and then you'll take the test after that. So let me know if you have questions.